Welcome to Gooseberry's Science and Education videos. My name is Joe. You might notice a little orange gooseberry character hanging out with us today. That's our trusty assistant who's going to help us navigate today's incredible journey. We are going to take a huge spatial adventure, starting from the absolute vastness of the cosmos and then zooming all the way down into the micro details of exactly how animals survive on this ever-changing planet of ours. Okay, let's dive into this. So to really understand everything on Earth, we actually have to start long before Earth even existed. I know, sounds crazy, right? But most scientists agree that literally everything we know, time, space, and all the matter in the entire universe kicked off with the Big Bang. We're talking about an unimaginably massive explosion. It was a fireball so incredibly concentrated that matter was just created, spontaneously, right out of sheer energy. In that exact split second of creation, the universe was infinitely hot and incredibly dense. And from there, it just expanded and cooled down to create all the galaxies and stars we see today. 13 billion years ago. Wow, that is a staggering number. It's honestly kind of hard to even wrap your head around that kind of time. To put that massive timeline into perspective for us, our own planet is a mere 4.5 billion years old. So in the grand cosmic scheme of things, Earth is actually a relatively young world. It's just been shaped and molded, kind of like a giant ball of putty over those billions of years. Fast forward to today, and we have this amazing ability to look back at our own dynamic planet using geostationary environmental satellites, or GOES for short. Now, what's really interesting about this is how they work. These amazing tools orbit at the exact same speed that the Earth rotates. That means they're literally locked over the exact same point on the ground at all times. From way up there, they monitor these massive weather systems, they snap pictures, and they can even measure the exact height of the waves churning down in the ocean. Seeing Earth from space like that really anchors our whole explainer today. It practically forces us to ask one huge overarching question. How in the world did a fiery ball of rock just floating out there in the emptiness of space become this lush haven? A haven teeming with millions of species, from tool-using apes all the way to globe-trotting birds. How did those extreme, chaotic early conditions end up birthing such incredible biological diversity? So here is our game plan for today. First up, cosmic origins. Second, the restless oceans. Third, mammalian survival. And fourth, masters of the sky. Part 2, the restless oceans, Earth's fluid world. Let's transition right out of orbit and splash down into the extreme aquatic environments that cover most of our globe. And this brilliantly illustrates just how incredibly extreme our oceans can be. On one hand, you've got the freezing world of Antarctica. Down there, emperor penguins are enduring plummeting winter temperatures of negative 58 degrees Fahrenheit. It's so cold that the males literally incubate their eggs by resting them right on their feet, nestled under a warm flop of skin. Now contrast that freezing landscape with a tropical mangrove swamp at low tide. When the water pulls back, it reveals this totally alien-like world of twisted roots inhabited by crabs and even snakes. It's the exact same ocean, but two completely different, mind-blowing extremes of survival. But, as you've probably heard, these distinct environments are changing. We're talking about global warming, the gradual increase in the average temperature across the world, potentially caused by greenhouse gases. To figure out what's happening, scientists actually drill deep down into the Antarctic ice cap to pull out these long ice cores. These cores are literal time capsules, packed with trapped air from thousands of years ago. By analyzing that ancient air, we can see how naturally occurring greenhouse gases caused global warming in the deep past. And this historical data is absolutely crucial, because we're seeing some really worrying signs today, like the massive Hubbard Glacier up in Alaska retreating and shrinking. Of course, we humans aren't just watching all this from the sidelines, right? We are deeply interacting with this fluid world. For instance, modern scuba gear allows explorers to safely dive down to about 164 feet to study these ecosystems up close. We're also actively tracking large marine animals by swiftly attaching satellite tags right onto the dorsal fins of sharks. And in developing tropical countries, families are actually farming seaweed on ropes held up by plastic bottles to make it income. And get this, incredibly, scientists are discovering that certain colorful sponges living on coral reefs produce powerful chemicals that can actually be used to combat devastating human illnesses, like malaria. How cool is that? Moving on to part 3, mammalian survival, intelligence, and adaptation. Leaving the oceans behind us, let's step onto solid ground, where terrestrial life requires some highly specialized behaviors just to stay alive. You know, a mammal's survival strategy is heavily dictated by one basic thing: its size. Take small mammals, like the tiny southern flying squirrel. Because they have a large surface area relative to their overall volume, they lose body heat incredibly fast. So to stay warm, they have to lead these fast, furious lives with totally frantic metabolisms. They're constantly searching for food, and they usually only live for a few years. But then, on the flip side, you have large mammals, like chimpanzees. They grow up very slowly. A young chimp will spend years and years just patiently watching its mother, learning really complex skills, like how to crack open a nut through trial and error. It's a completely different way to live. Let's move to and see how this builds into some absolutely astonishing displays of engineering. People used to think that only humans use tools, but consider the sea otter. This is brilliant. First, the otter dives to the seabed to grab both its food and a rock. Then it returns to the surface, floats on its back, and places the rock securely right on its belly like a makeshift anvil. Finally, it violently smashes the shellfish against that rock until it cracks open. It's a perfectly executed, multi-step engineering process. Just amazing. The sheer variety of physical adaptations on land is just wild. Seriously, some of this stuff sounds made up. Over in Madagascar, you've got the eye. It's a lemur with a specialized middle finger that looks exactly like a dead twig, which it uses to fish beetle grubs right out of tree trunks. Then there's the sifaka lemur. Its arms are so short that when it comes down to the ground, it actually has to bounce along sideways like it's on a trampoline, with its arms held high in the air just to keep its balance. And over in the steamy rainforests, orangutans literally build sleeping platforms high up in the trees every single night. They've even go so far as to build rain roofs, or they'll grab giant leaves to use as umbrellas when the weather turns bad. Finally, Part 4, Masters of the Sky, Avian Engineering and Endurance. For our final frontier, let's leave the land behind and look up to explore the unparalleled marvels of the bird world. If you think your daily commute to work is tough, consider this number, 21,750. That is the number of miles an Arctic tern will fly in a single year. Literally no way. These incredible little birds nest all the way up near the Arctic Circle in the summer, and when winter starts creeping in, they fly all the way down the globe to Antarctica, just to chase the summer sun. Okay, here is another mind-boggling number for you. I want you to imagine trying to gather 50,000 of something, anything, just to survive the upcoming winter. It sounds impossible, right? But for one particular species of bird, this isn't an exaggeration at all. It is a vital, seasonal chore that they absolutely have to do. So, the crucial point is, sometimes survival takes a highly coordinated village. Meet the acorn woodpecker. A single family unit made up of up to 15 members from multiple generations will meticulously drill thousands of different sized holes into a single tree trunk. They then hammer acorns into these holes, creating a massive communal pantry holding up to 50,000 acorns. But get this, the work never stops. As those stored acorns dry out over time, they shrink. So the family has to constantly move them around to smaller holes so they don't just fall out and hit the ground. It's a full-time job. Now, raising young in the wild is obviously dangerous, and the hornbill goes to the absolute extreme to protect its family. First, the female finds a secure hollow in a tree. Then, and this is crazy, the entrance is entirely sealed up with mud, leaving only a tiny little slit. The female essentially imprisons herself inside this dark hole for about 3 months. During this entire lockdown, the male works tirelessly on the outside, constantly passing food through that narrow little slit to keep his mate and their growing chicks alive. Talk about dedication. And speaking of unbelievable nesting techniques, consider the malleefowl down in Australia. This bird doesn't even sit on its eggs. Instead, it builds this massive incubator mound made entirely out of rotting vegetation. Just like a garden compost pile in your backyard, the rotting matter chemically generates heat. The parents then meticulously adjust the temperature of this mound by carefully adding or removing material. They pull this off without ever having direct physical contact with their chicks. So, from the initial spark of the Big Bang to the freezing depths of the oceans, and from tool-wielding sea otters to 50,000 acorns hidden in a single tree, our 4.5 billion-year-old planet is just a masterclass in adaptation. But as the Earth continues to shift, and as we look at the data from those ancient ice cores showing a warming planet, it really leaves us with a profound question. How are these ingenious creatures going to adapt next to survive everything on Earth? It's definitely a fascinating question to ponder. Please like and subscribe if you enjoy the content. We are already working on a new topic. Thanks for learning with me and our little orange gooseberry today.